Possible value only?
Which is I see.
No, that's something which is flagged as concrete, which is very precise. Constant with one value.
Yes.
Yes, good. Then we have, I mean, if two constants, if two different constants join or are joined with a variable, you get something that may be constant or variable.
So basically, yes. Okay.
Of course, this part here looks like nice annotations with a correct subclassing of generalization properties.
Yes, because you would go from this to this to this.
No,
But
no. From this to this or from this to this. This is the most general.
Yes.
But the reflowing needed by the flags doesn't work. This doesn't work this way.
no, the problem of this, what we need to think is what should happen when you need you fix and you need to. Also because in terms of union you get in this strange stuff. You get variable that gets reflowing with stuff
probably.
which is still different because you can have a fresh variable that you never saw. I mean, that is not annotated and you flow in it versus something that was annotated.
Certainly. Other stuff that goes.
Well, because you have something like some you have some impossible value in this picture too, which maybe it's still
Well, but
can be
this is
reused probably.
okay, I can look it up anyway. But what I'm not sure about is basically the time.
But then indeed the question is what happens
When you reach a field, then
yes.
in some sense, the clean thing would be to throw everything away and start again.
Yes,
But
it doesn't look like an efficient strategy. Maybe it's an danger.
then it didn't work.
No, because you still need to remember what you need still
What
to
you
do.
hinted.
Yes.
You see?
And maybe you can because indeed you need some indirection and then the indirection would remain.
These are all
Unclear.
correspond to.
But then it makes sense to do this bit here with normal annotation. Well, this bit here.
Well, it is bit here, but anyway, it is bit here need to interact somehow.
Yes, I know, precisely. The concrete can also be probably on its own. The only mess is fixed probably, no?
Yes, but concrete is what it means.
Concrete is a result, it's propagated forwards, normally concreteness. It's a result of a hint.
Yes, it's the yes, it is. It is false.
Yes, exactly. Good.
Which is indeed a
Carl
kind
had a nice picture with
I see.
space-time cone, and here you have hints, and here you have fixed, which is the past, and here you have concrete, which is the future.
Yes.
Of course. So maybe we could really call them past and future.
But then concrete is a kind of...
It's a constant that is something even more specific than constant.
No, it's more general than constant with one value. It's... between
maybe. Or is it more general?
Well, because this one... but...
Concrete has also one value.
But you don't mean that you know this value.
No, you mean, I mean that the abstract interpreter will only ever see one value for this.
If that
makes sense.
Because, yes. But I see, so yes. They have some relation.
Now, for example, if you fix stuff and you start computing from it, you get a constant with one value.
And then it's propagated until you
yes.
But when you do but indeed when you do the union of these two
different such things, then no, not concrete. Concrete is very specific. It's a result of hint.
Yes, but then you still indeed you need something in between.
You get this. No, you get this exactly.
Okay.
It's const if the value just happens to be the same still at runtime, or var if not.
But then it needs. But
no, well, this is the easy part. This is really.
Yes, but it means that if this meet a variable, it should not meet a variable. No, it can meet a variable.
No. I mean, concrete should be very local, like here. The concrete is really the opcode here, and the result of the equality and nothing else. They go in the test and they don't go further. So it's like everything is constant concrete around here, and you should compare if you need more.
I see. So basically, it's sort of where we have these things, and then we have concrete.
Yes.
And then fix is a strange state of things that
were. But this is still not clear. This is not just one nice annotation. I think we also need an indirection because we're interested in knowing if we are seeing another value, another constant with another value. The union of two such things is ever again such a thing if it's exactly the same, known to be the same value, or it's maybe const of var avoid.
You basically need to track them to their creation point
to know
track identity of these things somehow.
Yes. So basically we will need to track everything, I suppose.
Yes.
Also fixed could be solved in this way. Maybe.
And of course for fixed it means that variable you really need indeed each variable really need to have an indirection to something where you can...
I mean it starts to look like we really need some abstract value
which then has
always indirects. Or maybe this one can be some concrete value, but the rest is
C-type actually only as a kind of definition language when we are able to translate
concrete value, of course. Well, some LL concrete constants or something like this.
Yes, something. It's not really a problem. And then this would to something that is tied to
the actuation point. The first variable that contains
would be just
yes.
made enough to, for example,
plus some.
Yes, and then we have union of creation points. So we have a family of creation points here, or we eagerly do the union,
where we
with
make
a union
like
finder.
this. Yes. But we need something in that direction.
No, it's confusing.
Do we?
Or do we track explicitly the set of possible creation points? I think we have to kind of because here you have manipulations that like pop that gives you something. Well, no, not pop, but well, something that reads a value from the stack, for example, and later propagates this value in a place where it should become fixed.
Yes, which means that you really need to track. Well, indeed, you need to track the dependencies.
Or yes, yes.
Which indeed also already in the LL abstract when you
Yes,
join,
sorry,
you need to do the union of the dependencies. Yes.
Yes. Okay. So this would be something with an origin. Which is
Or even more multiple, yes.
Multiple or something, yes. Origins, yes. That's it.
And then flags. But then the fun question, of course, indeed, is what happens when you set fixed these things. You need to reflow from all. You need to set fixed.
From all origins, basically. You need to fix all the origins.
And all everything that in between, yes.
Yes. Yes, I mean, origin could be thought of as a tree, maybe, dependencies. And then you fix all the trees.
Yes. But then what happens when you reflow with this fix? Because this fix will encounter things that were annotated. No, because no, indeed. Because the variable or not variable, it's here. So
Yes.
you encounter yourself, basically. You change yourself.
Then do we need to reflow? I probably follow the outside dependencies that go outside.
Yes. No, it's not completely clear. Do we need to reflow? Yeah, because this variable could encounter, because the question is what happens if a constant encounter a fixed or there are a lot of potential combination, which is a bit unclear whether they will happen or not.
Confused. Doesn't work. Origin is no something that origin in some syntactic positions is probably not enough to do something interesting.
No, but the other one was tracking really the dependencies, not only the origins.
Yes. Yes. So we should probably. Yes, an origins.
It's only used to yes, well, yes, it's not where you come from, but it's really.
Yes.
You need the tree of your dependencies.
Yes, but the tree, what, syntactically or more dynamic? Syntactically, it's not enough to what this can do. I suppose we should think about a simpler example. Where there is one accumulator, so small interpreter with one accumulator, and sometimes you use the accumulator to do arithmetic operations, and sometimes you store a value in the accumulator which is used then as jump offset, for example. So we once know that.
And if you would need that, you really need to split your graphs.
Supports a general thing, something that's doesn't know yet if it's how fixed it is, how I see.
You really.
No, yes, you need to support something that doesn't know how fixed it is. Probably.
There is in open other type.
Yes.
How fixed it is. I see. Ah.
Yes. Well,
Basically, one of these
thing
things
about PyPy, it's a case where you load the constant in the bytecode in the stack. And
yes,
then
but,
do something.
but indeed it means that this is not just about you need a set of places that fix it. Or
Well, but if you think about this example of the accumulator, maybe we can say as a kind of middle ground that the accumulator can, well, that basically in the case where you would like then nature to be fixed, what is in the accumulator, corresponds by chance to the case where you have a constant in the accumulator.
yes, well, but we know indeed that in some cases what enter here it's already
Constant, yes.
in that case you kind of
Yes.
wrap it because you don't have to fix anything.
No, you mark them fixed, but
Yes.
you don't have to reflow, to restart. But maybe we can try to have some more formal definition of what we allow in the hint, which would include these cases where the LL abstract interpreter would always arrive with a constant.
So yes, but well, but indeed I see. But anyway, this is the case here. Here we have a constant. I will refer.
Wait, if you pass just constant with one value instead as input or input,
Yes.
you get a constant here. You don't need flow back.
No.
You don't need to apply those into constants, maybe that helps.
Yes. But indeed it's very unclear, but it was always very clear to do this job.
Yes. Yes, here. Well, I suppose the real goal would be to figure out that, for example, because this is passed to hint, this, which is originally constant with one value, but I mean, for example, the PC can take several values, so maybe here we get a maybe var of const for PC.
Yes.
And then we get in with maybe var or const, so the goal would be to revert this maybe effect by figuring out that at this merge point here, it was a bad plan to merge the PC. That was the goal of the runtime fixed flag.
Which means that this should, instead of this, it's really going from back from here to here.
Yes. Something like this. Maybe we can again use something similar to fixed in some way.
Well, that way, indeed, if you have a maybe const or var and you fix it, it means again.
Yes, well, we could also distinguish between constant with one value and then, for example, I mean, maybe constant var that comes just from the union of such stuffs, or the one that can really contain a variable, which is hopeless for him.
I see. Basically, if this you.
Yes, I mean, you would have another notation which is result of a merge of constants, something like this. Which if it stays this way is just interpreted as a variable at the end. But if it's if there is a hint, then you can trace it back and something like this.
Basically, distinguish if you really do the union of a const and a const versus
Yes.
constant.
Yes. maybe.
And then indeed it means that we don't try to fix variable at all.
No, no.
We only try to fix this kind of thing. Which means that we don't need probably to reflow.
I mean, sometimes there are not many variables anyway. If we pass constants and we put arguments anyway, we get mostly constant anyway. We get variables for operation side effects. That's the thing that is.
Yes. But it means that the state between this and this, it's it's flags. They are not really
Constant
No, but there are lots more stuff than just
no, but it looks again more like something that can be done with reflowing. With normal annotations, that's normally reflow. We go from constant with one value to the more general constant, maybe generalized constant.
Yes, but then you want to revert.
Constants, basically.
But if you want to revert, you cannot reflow. You cannot simply reflow because the contains will.
Yes, of course. No, but maybe the fixed can be. You have constant with one value optimistically propagated. Then more generally, you have constant with multiple values that may have been generalized. And then still more general, you have family of constants that are mutually incompatible, which is of course more general than the other. Because it's continuity.
Yes, you cheat.
I know.
I see. Which of course.
No, maybe not. Yes, but no, maybe then you can have origins somewhere.
Yes, and fix. Fix. We'll move this back to.
I don't know, back to some kind of base class that then say, oops. Well, no, I mean basically from constant with one value to constant with multiple possible values, which itself has an interaction in which we can say later fixed. Looks like a better method.
Also, because indeed, if yes, but the question is still then: we have a place where to put the flag, but do we need to reflow or not?
Well, what does the if you put the flag fixed, then what occurs? What does it change really?
What kind of union would change because it's fixed?
Yes, so what kind of operation would give a different result? If you add the fixed on another constant, you get a constant anyway.
Because anyway, this should really be, because these things start from things like this or like this, and then you get here, but then you should only propagate.
You get answers that have anyway back pointers, so
you should be able to just get the effect by patching yourself.
yes. Then we use that fixed point thing only for, well, basically fixed point, forward fixed pointing of the loop.
To go from here to there,
Yes.
and to this and this to this.
Yes. Maybe conserver is kind of, yes, indeed. Well, to some extent, maybe conserver can also be a give up variable.
Yes. Then we are trying to fix variables.
The hope is that we don't try to fix things that could have another variable in the history. It probably makes some kind of sense, because then if we go more cycle-wise, you would get things that, I mean, the hint, we cannot in a full Python
Yeah, I
interpreter
hope
just
to
use hints.
yes.
We also need another thing a bit earlier. That
Well, we
this
need
variable
int, but
should
int
be-
that really means you will really get some runtime value, and you really need to.
Yes, but I'm more thinking about putting the hint where it's really needed, which means, for example, this is the method, this is the function I want to call.
Trying to make more sense or everything.
Or, see?
This is
No, go from an object to its type, to the type table, to the function we call. The hint is on the function call. Like it's easy to determine where hints should be because on indirect function calls you usually need a hint. The hard part would be to put another function, another thing which you put on the type precisely because that's what you are usually interested to move from runtime to compile time.
yes.
From
No,
variable
but
to constant.
but you are.
And this other thing would be what turns a variable back into a constant with one value.
But the one on the function. No.
So the one on the type. You read the type of the object. You say
I see.
you say unlift.
Yes, you
You
see.
get a constant with one value that goes a bit somewhere. And then there is a hint which is happy because it's constant rising.
I see. You would mark instead of.
Yes. And I mean, in a large program, this kind of code would probably mark the code at the beginning or something. Here is a good place to start considering.
Instead
this.
of marking the variable, you really mark places. Yes.
Yes.
Of course, it's not clear in PyPy because the type is not really. But that's a different kind of niche.
Well,
Start to code some of this.
I'm very confused about what more precisely
This means. Of course, I feel that it really means something syntactical because unless you split your graph or
no, but no, definitely.
well, the fact is that you have to kind of, I mean, you have really operation and you have join points.
Yes. I think the join point can just take the union of the origin, whatever that is, in general.
Yes.
Then you have creation points, like you create this by addition of these two things.
Yes.
Then,
Your original are the corresponding boxes of the two things that arrive.
okay. Probably then we get a very dynamic effect again, which makes me happy.
Because it's you're really interested in the box because it's the place where you need to switch between the
But there are situations where you compute stuff. No, if there are no situations, no. What can be fixed? Ultimately. If it's constant that's created by another operation, then the arguments themselves will be fixed.
Yes.
So if you follow, you arrive at what? You arrive at
Well, you arrive where you are.
constant in the graph.
You arrive at
Or
constant
input
in the
arguments
graph
maybe.
or input arguments.
So if you arrive at a constant in the graph, fix a constant in the graph.
No, well, you arrive back with indeed constant with that value which already it's fixed in
Well, is it?
Yes,
Ah,
the
you don't care
constants are
in this.
fixed. Yes, I mean you don't really care about the constants in the graph as such.
You can always mark them as fixed anyway, because anyway they are not, well, they are just one value anyway. No, wrong, no. Not in the abstract interpreter, you can have two constants in the graph that go into variables, I mean like local variables.
Yes.
Then you merge them.
Yes, but then you get kind of annotation.
No, but being fixed or not is, well, yes, I see. At least today you don't care. And then if this thing is fixed,
Yes.
then it means that the time you should not merge.
it means this kind of annotation really means that when you are typing, you really need to indeed split. Yes.
But no, but if you don't know, if you propagate two such constants, you get this when they unify.
Yes.
If only if this is fixed, then you should split. Okay.
But it's this that then will have its own box that contains the boxes of these things that, well,
You don't care
Yes.
about the fixed flags.
but you care very much about the fixed flag.
This makes a lot of sense.
Maybe. Because indeed it means that when you get...
See, but then it's more precise that what the electric interpreter is doing. Because the electric interpreter is putting a fixed flag on stuff here maybe.
Yes.
But maybe the same thing can wander around somewhere else, being passed around and then prevent unification somewhere else, which is a bad effect. But you are doing something more precise in this sense.
Yeah, but of course we still have the problem that the argument itself can be variable and maybe...
No, well, variables mean give up.
Yes, so we should never start with variable for the argument.
Yes, exactly.
Because
Pass constant with one value optimistically as input arguments and see what occurs. So, do we make this normal annotation or we box everything?
no, it seems that we need to box because when we fix
Or maybe no, but this can be a normal annotation, but with just an origin that goes. What is the box?
this, yes.
Maybe.
This is to be that.
In some sense, these are annotation. This may be annotation to which we attach a set of origins, and then, theoretically, independently, some origins are marked fixed or something. Wrong. Yes, but this is a new origin by itself.
Yes.
I see the box, so it has a new box anyway.
Yes, because each time you are about to create, yes.
I see.
It's the result. The result will have its own box and no box. Yes.
Yes. Each time you flow, you create a new box. You don't attach to the variable, you attach dynamically to the annotation.
No,
Yes.
you keep the box.
No.
Yes. What do you? I fear that we start to remind me of strange discussion in Amsterdam about
I agree.
boxes.
I see very much. However,
Yes.
of course,
if you attach box, then
again. Of course, I see.
And yes, I guess the white is
if you have boxes,
and you attach it to the merge point precisely, but
Yes.
then it can go a bit on its own somewhere.
yeah,
You don't really attach it. Yes,
you don't attach it. Yes, I mean
I see.
it's the merge point or the point where yes.
So the merge point has a box,
And the box then can be yes.
and your box can.
Well, it's a bit like lists.
I see. Yes.
A bit.
It's the auxiliary variable in the theoretical model.
Yes, indeed. It's still It's still auxiliary. Yes.
No, but merge points don't have one, I think.
No, because they really are expressed directly as union on what arrives. That's
I see. No, but we cannot do this. Then it's different. No? Because we want to be more precise. Because if these two constants get merged here, it's not the same as if they get merged there. We want to keep possibilities that one gets fixed and one doesn't.
yes. That's why
Which is not the kind of thing which we try to do with this, so it's a bit difficult, I think.
And indeed, then from this point, you propagate a box that that has origin that are really the origin that you see there, and then you fix what you see in the box or what arrives here, which of course is not you don't unify everything. You care about the box of the things that arrive there. Of course, then you need to fix everything in the tree, but the tree is still not.
So we have a tree of boxes.
Mm-hmm.
Box has origins. Yes, I see. We probably only need one annotation that points to the box.
Yes.
Because the box is clever enough to know if it has several origins or not anyway.
Yes.
And it has a fixed flag.
Yes, indeed, having multiple origins,
It means this, yes.
and then also
But this can be a give up. For now, I would say we have some variable which is a base class, which is a give up completely.
Yes.
That covers all these cases.
And then indeed, if such a thing arrives to a int, we
complain. Yes, and this is anyway a different problem still. Never.
Yes, it's
Yes,
still.
exactly.
So we would have kind of.
A base. A base, I have no clue. This and some LL constants or something.
Okay.
Okay.
Yes.
Programming time.
Yes, programming time for
Types. Test.
Well, we have a test.
Yes, but what is exactly testing? No,
Nothing.
Not a clue.
Nothing.
Precisely.
But indeed, we need to fix. Well, we can really make the test something.
Yes. Good.
Now
It's
that we
hint
have an
annotation, but it's testing the file hint annotator without underscore.
Yes. Well, life is.
Of course.
Identity, yes, this plan is very wrong.
Yes. Yes. So we need boxes and stores and in LL, some LL constant. Well, abstract somewhere would be nice. An abstract constant for
Yes.
the longest line in PyPy ever is the box creation code in addition.
Well, but we probably need a helper in here that does that for us. Also because the box need to be stored somewhere.
No, well, we can. Let's try with just a tree of boxes for now. Intro see the tree of boxes and go back. The concrete type is here. Yes, probably. Some box. No, bad move. Well, something about origins maybe. Origin tree node or something. It's kind of like explicit.
Yes, and then we
No origin. It itself has origin somehow, no?
itself.
I was more thinking about the real tree, like this leaf.
But anyway, just whatever operations are.